Venom. Poison. Wild cocktails of death. The animals that carry deadly toxins are often the creatures of our nightmares. Yet venom is one of nature's great masterpieces. And those organisms that combine individually innocuous chemicals into fatal mixtures are indeed nature's deadly alchemists. Alchemy was the ancient art that tried to transform base metals into gold and create a medicine that would cure any illness. The ancient chemists failed, but 500 million years before them, nature succeeded. Venom was created. Tiny living creatures in the oceans were the first to combine mixtures of peptides and proteins and transform them into the potent and lethal cocktails that are the venoms and poisons we know today. Venom is nature's oldest and most efficient weapon. The first arms race was driven by chemical warfare, and today, there are creatures that survive almost unchanged from that time. Drifting in the open oceans, they must be certain of catching prey. The tentacles of the lethal box jellyfish drift below its bell like a deadly web. They not only harbor a toxic cocktail, but they can deliver it, for venom can only work when it is injected into prey. Each tentacle carries tens of thousands of nematocysts, deadly darts that deliver venom directly into the bloodstream of anything that brushes against them. The effect is immediate: paralysis and death. For the jellyfish, this is crucial. It has no means of grasping its prey. Venom is offensive, while poison is defensive. Animals that are poisonous often announce their threat with garish colors. They warn predators, danger, don't touch. In the first days of life, the oceans were a toxic wonderland. They still are. Vividly colored sea slugs called nudibranchs save energy by producing their poisonous defenses from what they eat. Since venoms and poisons require energy to create, some animals take a shortcut. They repurpose toxins they ingest from sea sponges and the stinging cells of hydrozoans. These small communal organisms were among the first to produce venom 600 million years ago. But nature plays another trick. Not every brightly colored creature is poisonous. Some nudibranchs that display bright colors are just mimicking the dangerous ones. Venom and poison are nature's ultimate weapons, so adaptive and versatile that they have evolved almost 90 separate times in the animal kingdom. Flatworms were probably the first creatures to bring venom onto dry land. An exact date is uncertain, but it's thought to have occurred around 550 million years ago, just 50 million years after marine venoms first appeared. Then plants evolved on land, and with that came an explosion of life. Around 420 million years ago, centipedes were among the earliest venomous terrestrial creatures. They don't have fangs. Instead, they use a specially adapted pair of front legs attached to venom glands. These sharp claws inject the venom into prey, killing it quickly. As life evolved, venom evolved with it. For toxins to work rapidly, they must be target-specific and delivered efficiently. "400 million years ago, the tail of the scorpion evolved from an egg-laying tool to a venomous weapon. The front pincers are for grasping. The deadly sting is in the tail. The toxic molecules of the scorpion's venom target the victim's nervous system and rapidly immobilize it. Spiders are related to scorpions. Both are arachnids, but the jaws of spiders evolved into fangs, the ultimate delivery system for venom. The toxic cocktails they inject immobilize and kill their prey. They also help the spider to pre-digest their meal so they can suck it up, sometimes from the still living victim. Nobody is certain if the first spiders were patient web spinners who ambush their prey or active predators, but almost all are venomous. One of the deadliest is the Sydney funnel-web spider from Australia. Large, aggressive, and with needle-sharp fangs that can penetrate human fingernails. This is the spider of nightmares. Unusually amongst spiders, it's the male that is the deadliest. This funnel web's venom contains a unique component called robustoxin, highly effective against the spider's prey of small invertebrates and millipedes. When they strike, they bite repeatedly, injecting venom until their victim is paralyzed. In a strange quirk of evolution, the funnel web's venom has a catastrophic effect on the nervous system of primates, even though the spider evolved on a continent where, until relatively recently, there were none. The neurotoxins short-circuit the nervous system, triggering heart palpitations, increased blood pressure, respiratory failure, and death. Until 1981, when an antivenom became available, funnel webs killed at least 13 people. One 4-year-old boy died in just 15 minutes. Spiders are the alchemist's dream, creating a venom for just about everything, even other spiders. The Portia is a jumping spider that hunts spiders. All jumping spiders have keen eyesight and rapid, often erratic movements. They hone their hunting tactics by trial and error. It's a battle of wits. Mimicking a dead leaf, the portia is patient and relentless. She mesmerizes her victim. And it's over. The redback is another deadly Australian spider, with venom so potent it can kill a human. The female lies in wait in her web, not just for prey. She is also guarding her egg sac of young that have recently hatched. She has poor eyesight, but is alert to any vibrations on her web that tell her of trapped prey. She's able to differentiate between the movements of prey and her young. And the portia knows this. Her venom is unusually powerful against other spiders. Even those many times larger than herself. But her eyes are on easier prey, the redback babies. She gently strums on the web. Her movements reassure the mother that she is no threat. She moves with care and cunning, always aware of the lurking presence of the deadly female. In this struggle of venom against venom, intelligence wins. Every living creature has the alchemist's potential to evolve its own venom, but the most numerous are insects. They first appeared over 400 million years ago. And there are now over 150,000 species of insect that deploy venom. Ants evolved relatively recently, around 100 million years ago. But they are by far the most numerous insects. Amongst the most vicious of the venomous insect armies are bulldog ants. A native of Australia, they can grow up to 40 millimeters long. They are renowned for being aggressive and will attack anything, regardless of size, at the slightest provocation. Armed with large and ferocious jaws, any bite can be exceedingly painful, but not deadly. The sting is in the tail. The venom delivered directly into the body of its victim is one of the most toxic in the insect world. But unlike bees that lose their life when they sting, bulldog ant stingers are without barbs, so they can sting again and again and again. Bulldog ants use their venom both in defense and attack. Despite their ferocity, the adults mostly eat nectar. It is their larvae that are carnivores. The hunters take insect prey back to the nest for them. They are ferocious predators. Because of their great numbers, they have a limitless supply of venom. Once inside their nest, the workers use their vicious jaws with tender care to feed the larvae. As well as hunting, their chemical arsenal has another purpose: to defend their queen. For she is the mother of the colony. All the eggs are hers. Once they are laid, the next generation is cared for by the workers. Finally, the adult-sized ants hatch out, each primed with deadly venom ready for immediate use. Fortune doesn't always favor the venomous. Ever since venom first appeared on the planet over 500 million years ago, a chemical and biological arms race has raged. As one venom evolves, others will develop ways to combat it. The flat caterpillars of an Australian gum moth invade the nest of weaver ants to devour their young. If any other caterpillars were to try and break into the ant's nest, they would quickly be stung to death. But the moth caterpillars have developed their very own survival kit. A hardened outer layer deflects the ant's venom. Sucker-like feet anchor the body to the nest floor, preventing the ants from attacking the caterpillar's vulnerable underside, no matter how hard they try to flip it over. As many as 6 caterpillars can invade a single nest and feast at will. Despite their numbers and their venom, the weaver ants are helpless. There is another powerful defense against venom: poison. In South and Central American rainforests, poison dart frogs evolved around 40 million years ago. They stand out vividly from their background. Their lurid colours allow these frogs to be active in the day. The most distinct colours signal the strongest toxins, some of them the most toxic alkaloid poisons known. Bright enough to warn off a stalking tarantula. They evolved their bright colours at the same time as they became toxic. These frogs collect poison from the toxic ants and beetles they feed on. They harvest the dangerous chemicals and store them in their skin. None of them is able to produce their own poison. In Australia, there is one poisonous frog that does it differently. The corroboree frog is the only vertebrate in the world that actually creates its own poison and then secretes the toxic alkaloids back into its skin. This frog, now critically endangered, is one of nature's ultimate alchemists, creating a unique substance from simple compounds. Poison acts differently to venom. It is created from organic compounds that don't break down in stomach acids. Poisons enter their victims' bloodstreams through digestion. Venom must be delivered by violence directly into the bloodstream, yet the deadly compounds are harmless if eaten. Some monitor lizards, like the Australian parenti, have only recently been shown to be venomous. Both the parenti and the Komodo dragon have oral glands that produce venom. Once the victim is bitten, venomous drool enters the bloodstream and slowly, painfully kills. Both giant lizards follow their victim as it dies. No need to expend energy with a fast pursuit. Their venom does its job well, but its delivery is primitive. By far the most efficient and sophisticated venom delivery method is by fang. Nature invented the hypodermic needle long before humans were on the planet. A method of injection perfected by spiders and snakes. In an almost incredible example of coevolution, there are over 200,000 venomous creatures on the planet. Just 600 of those are snakes. And this Australian snake is the most venomous of them all. Science has estimated that the venom from one bite from the inland taipan could kill 100 adult humans. Left untreated, a victim would be dead in 30 minutes. But humans seldom ever see this snake, let alone get bitten by it. It lives in arid inland Australia, far from most humans. During the day when the ground temperature can exceed 50 degrees Celsius, it only moves when it must. Preferring to shelter in cracks in the ground. Inland taipans always prey on small mammals. Its venom has evolved to be specific to that prey. The deadly cocktail contains neurotoxins that attack the central nervous system. Other toxins target the blood, kidneys, and muscles of its victims, an assault on all the vital systems of the body at once. This inland taipan has sensed prey. Like all venomous snakes, it can only attack with its head, the most vulnerable part of its body, and rats can bite back. The taipan is cautious. When it does strike, it will attempt to inject venom deep into its victim. In this arid country, prey are often few and far between. There is no second chance. One reason why this venom has evolved to be so powerful. Hit with this venom, the rat could be dead even before it is paralyzed. But if it is able to move at all, it will be slow and the snake can follow. Job done. Dislocating its jaws, the taipan will swallow the rat whole and then slowly digest it. It will be weeks before this snake needs to hunt again. The parched and cracked earth not only protects the adult taipans from the sun, it is also their nursery. Females use abandoned burrows or the deep cracks to lay clutches of over a dozen eggs. Then she leaves. Like the offspring of most snakes, when they hatch, they are on their own. As soon as they emerge from the egg, the infants are just as venomous as the adults, but they are hatching into a hostile world. Instinct is their only guide. And instinct tells them that survival depends on moving to the surface, dispersing, then seeking out prey. Instinct does not warn them of their greatest danger. The mulga snake is one of the longest venomous snakes in the world, growing up to 3 meters. They are active hunters, and baby taipans need to be wary. This snake is a snake killer and has evolved an immunity to other snakes' venom. The baby taipan senses the threat. With no place to hide, it freezes, hoping the danger will pass it by. Finally, in desperation, the taipan strikes back with needle-sharp fangs dripping with its usually deadly venom. Another snake that won't need to hunt for a while. Venoms are constantly evolving to suit the specific needs of the hunters. As recently as 10 million years ago, some snakes evolved to return to the sea. As their environment changed, so did their senses and their venoms. Specially adapted sensory scales on their heads can detect prey by recognizing water movements caused by beating fins or flippers. Their venom has evolved to be lethal and fast-acting, since a fish could easily slip out of their jaws and swim far away before a weaker toxin could take effect. Evolution is a two-way street. Venom requires a lot of energy to produce, so one species of sea snake that now only eats fish eggs no longer has the need for venom. Rather than waste energy, the snake has evolved to no longer create venom it no longer requires. Venom is a precious commodity. Some animals can make a conscious decision as to how much they inject. Spring in Australia. Many snakes emerge from their winter hibernation. Not only are they looking for prey, but the males are also looking for a mate. Two male red-bellied black snakes fighting over the rights to a territory. These snakes hunt reptiles and other snakes, including their own species. When bitten, the other male's immune system kicks in, and the venom has no effect on him. Oceans were the cradles of evolution. It was here that venom first appeared. One of the very first venoms was tetrodotoxin, an alchemist's dream that has proved so powerful many creatures are still producing it 500 million years later. One is the blue-ringed octopus, found along the southern shores of Australia. The evolutionary history of the octopus family is still uncertain, but the blue-ringed octopus is believed to have evolved recently. Just over 4 centimeters long, it is one of the deadliest marine creatures on Earth. Venom from a single bite could kill 26 adult humans, but it gives a clear warning. When threatened, it flashes its iridescent blue rings. This octopus is an active predator, and crabs are a favorite. Tetrodotoxin is created from bacteria in the salivary glands of the octopus and is a potent neurotoxin. When injected into the bloodstream of prey, the venom causes almost instant paralysis of the respiratory system, a quick death. But the blue ring can kill in another way. So versatile are its toxins that if released into the water above a victim where they can be ingested, they act as a poison. This tiny octopus is both poisonous and venomous. The chemical arms race created by the first venom still rages. Scorpions are plump and juicy. A good meal so long as the sting in the tail can be avoided. The scorpion's venom evolved long before mammals. In Israel's Negev desert, a hedgehog likes nothing more than a scorpion for dinner. This hedgehog has evolved a countermeasure to the scorpion's venom. Circulating proteins in the hedgehog's blood bind the venom proteins and stop them in their tracks. The venoms can't lock onto the nerves they target, and the hedgehog's gain is the scorpion's loss. Venom is the most diverse, versatile, sophisticated, and deadly biological adaptation ever to have evolved on the planet. It may be an alchemist's dream come true, but for it to work effectively, it must accurately pinpoint very specific targets within the victim's body. So even if a tiny amount is injected, it will wreak havoc quickly. It's precious for the animals that use it. And strangely, it is for humans too. Science can now break venoms down to their molecular levels, not only creating antivenoms, but also discovering that venom can be used to help defeat diseases. The Gila monster, a slow-moving and venomous lizard from the southwest of the United States, is a binge eater. When chewing, it produces a peptide that lowers the glucose levels in human blood, and this helps with treatments for type 2 diabetes. Venom from a sea anemone, one of the very first venomous creatures on the planet, is being trialled for use in fighting autoimmune diseases. And venom from a rattlesnake that kills its prey by stopping blood clotting is being used to prevent heart attacks. With over 200,000 venomous creatures, it's no surprise that they can come in all shapes and sizes. Venom is often associated with reptiles and insects and spiders. And it's commonly assumed that mammals are the victims. But nature loves to surprise. There are only 2 mammals anywhere in the world that produce venom. Both use their toxins in strange ways. Perhaps it's no surprise that one of them is Australia's oddest animal, the duck-billed platypus. Everything is strange about this egg-laying mammal that may be the evolutionary link between reptiles and mammals. The male has a claw on each of his back legs that can inject a potent venom, but he only produces this venom during the mating season. It's now believed this venom is only intended for use against other males when fighting for a female. Southeast Asia is home to the only other mammal that is venomous. The slow loris, like humans, is a primate. It produces venom from a gland on its arm. As it grooms, the venom enters a unique structure in the mouth called a tooth comb. The chemical composition of this venom is complex, containing over 200 volatile compounds. If the slow loris bites, then the venom is injected. However, it is mostly used to protect its offspring. An adult will lick the venom over its offspring, guarding it against predators. So the slow loris uses a venom as a poison. There's another primate that is known to use venom, but the venom comes from millipedes. Only recently observed, red-fronted lemurs from Madagascar not only eat toxic millipedes, they also rub them and their toxins over the exposed skin of their genitals and tail area, a behaviour known as self-anointing. The millipede's toxins contain a substance that is a chemical cousin to quinine, used by humans to repel mosquitoes. By smearing the toxic juices over their bodies, the lemurs can get rid of external parasites. And when swallowed, the toxic juice might help to clean out those parasites that live in the lemur's digestive system. These lemurs have discovered that toxins can be used to their own benefit, and they're not alone. For thousands of years, hunters who couldn't create their own venom knew its potency well. They still do. On the fringes of the Kalahari Desert, the San Bushmen still hunt in the traditional way, using arrows tipped with deadly toxins that are carefully extracted from the larvae of a beetle. The San hunters know how to treat the poisonous compound so that it will still act as a venom. Now it is only toxic to mammals when injected into their bloodstream. The arrows are painstakingly prepared before the mixture is smeared on, then bonded with heat. The San method of hunting has not changed in ages. The tradition and the use of venom has been passed down through generations. The hunters seek out their target with knowledge, then use stealth to get within range. Once the arrow is embedded in the prey, the venom enters the bloodstream, locks onto its target, slowly destroying the red blood cells. The hunters follow the tracks of the dying animal, sometimes for days, until they find their victim and can carry it back to their village. Humans must use second-hand venom. But of all the venomous creatures, for humans, it is the small and almost invisible ones that cause the most suffering. Tiny ticks crawl onto both people and animals, injecting toxins that can cause paralysis. Leeches inject saliva that contains an anticoagulant that maintains blood flow as they feed. And the most deadly by far is the mosquito. To breed successfully, the female needs nutrients from blood. She zeroes in on any mammal she finds, and increasingly, those are human. Her needle-sharp proboscis pierces skin, and she knows how to find the veins. As she feeds, her toxins flow into the blood, but they don't kill. It is the parasites and viruses that she infuses into her host that are deadly. Malaria, dengue, yellow fever, encephalitis, just some of the diseases she gives us. Mosquitoes kill more humans in a month than every other venomous creature combined manages in a year. But because her own toxins are not fatal, she is not counted as a venomous animal, even though she targets people directly, something no other venomous creature does. The world of venom is astonishingly diverse. Venomous animals have evolved and adapted to almost every corner of the planet. They come in all shapes and sizes, with venoms and poisons that are constantly changing. Since venom was first created, it has constantly changed to suit a changing world, but has never lost its potency. Even today, in shallow, warm seas, when conditions are right, microscopic dinoflagellates and other planktonic life multiply into vast swarms, releasing toxins that poison the surrounding waters, killing marine life. Nature's first minute alchemists still produce a toxic bloom that can be seen from space. In a relentless evolutionary struggle started 500 million years ago, poison and venom were nature's ultimate weapons, and they still are.